Hello, Mr. Brown here, your science teacher. I make videos for students of all ages, and today, gather the family because we're going to talk about the science of chemistry. So, what exactly is chemistry? Let's break it down really simple. Chemistry is all about curiosity. If you wonder what is stuff made of, you're a chemist and you are conducting chemistry. Simple as that, right? And so chemistry is an ancient science going back thousands of years, which got me thinking, how far back? What were the first chemists? And I think about it and I come up with this little story. So join me as we go back 600,000 years ago, somewhere in Africa, a family is sitting around the campfire making dinner. One of the kids is throwing pebbles into the fire and noticing that the flames turn green. That's some pretty cool experimentation there, kid. The next morning, however, the family wakes up, they're digging around the pile of ashes from the night before, and they make a surprising discovery. Turns out one of the rocks happened to contain copper, which melted into a puddle during the fire. The next morning, it cooled and solidified. Chemistry is born. Now, did that happen? I don't know. I'm just kind of speculating as to how early peoples began chemistry. It's tough to say, but we do know that it's based on curiosity. So fast forward a couple thousand years, we are in the time of the ancient Greeks, about 400 BCE, and they're curious. And they're thinking that all the stuff that we see is made of four things: fire, water, air, and earth. Seems pretty valid to them. However, this line of thinking doesn't work so good as time goes on. Other scientists are like, what? That something's not right here. You're telling me everything is made of these four things? Something doesn't jive here. All right, so what we really see is the behavior of water. All right, so this is a simple experiment that can be set up. You take some water, two pencils, a 9-volt battery, and all of a sudden bubbles start forming here. All right, this is kind of a breakdown of how this early study began. This is called the electrolysis of water. And what it does is you run electricity through water and bubbles occur, except not the same bubbles. On this side, we've got bubbles, and we are going to name this gas oxygen. And on the other side, we have a different gas. So we're going to name that hydrogen. It doesn't matter where you are, anywhere in the world, any water you use, every time you do this, you get a 2-to-1 ratio. 2 parts hydrogen to 1 part oxygen. That's why we call water H2O. And this is where the study of chemistry really takes off, when we discover the chemical formula of water. Okay, so far we've discovered copper in our fire pit. We've discovered oxygen gas. We've discovered hydrogen gas, and many other discoveries are starting to pile up. We need a place to put them. Is there a chart that we can keep track of all the elements? And of course there is. Welcome to the world famous periodic table of elements, a beautifully colorful table showing every single piece of matter in the universe. Everything shows up on the periodic table. Okay, well, here's a question. Does it have to be in this grid, or can it be arranged in a different way? Well, yeah, actually, there's several different ways people have proposed. Here's one that's still valid. It's a spiral formation. Here's another one that's got kind of a twisty, loopy thing. Here's another one that gets a little crazy. This one uses triangles. This one uses 3-dimensional cutouts. they're all valid, they all work, but in the end, scientists have agreed on this shape for the periodic table for a couple reasons. It tends to show things a little bit more clearly, and you can see some of the families here: alkali metals and noble gases and transition metals. So it turns out this was not accurate at all. There are actually, so far, we've found 118 elements in the universe, not just these four. So now, armed with the power of the periodic table, let's get curious and walk around our world. Okay, hey, so what is air? Right? I don't see air show up on your periodic table. So what is it? Well, it doesn't show up because air is a complex mixture of different gases. You got nitrogen, oxygen, argon, carbon dioxide, ozone, hydrogen, neon, helium, methane, krypton, and a variety of other things, all of which show up on the periodic table. Oh yeah, well, what is fire then, huh? That doesn't show up on your precious little table. Well, fire is actually a combustion reaction with a fuel, oxygen meets heat and gives off carbon dioxide and water. All of these components show up on the periodic table. Well, what are people made of? I heard that little boys are made of snips and snails and puppy dog tails, and little girls are made of sugar and spice and everything nice. Hmm. Well, that's false. People are made of oxygen, carbon, hydrogen, nitrogen, calcium, phosphorus, and others that all show up on the periodic table. Now, I made another video and we talked about ocean water is poison. You can't drink ocean water, it'll kill you. Why? What's in that stuff? Well, elements off the periodic table. This is what's in ocean water: chlorine, sodium, magnesium, sulfur, calcium, and other stuff. All right, Mr. Smarty Pants, what is the Earth made of? Does your little periodic table have that? Well, actually, yes. The Earth is made of oxygen, silicon, aluminum, iron, calcium, sodium, potassium, magnesium, and others. And what's kind of interesting is you can see most of the Earth is oxygen and silicon linked together, which forms sand, silicon dioxide, sand, quartz, rock. All right. Well, your precious little periodic table doesn't work in space, does it? What are the clouds of Venus made of? Well, carbon dioxide, sulfuric acid, all of which are found on the periodic table. Well, does it work on Mars? What is giving Mars its red color? Does the Martian chemistry use a different period? No, it's the same periodic table. That's iron oxide or rust, iron and oxygen, right off the periodic table. At Mars's North Pole, here we see from space, there's this white stuff going on there. Can we describe what that is? Yeah, that's called dry ice. It's just solid carbon dioxide. What about Jupiter? This is a complex blend of stuff. There's no way the periodic table can handle Jupiter. Well, sure, why not? It's got hydrogen, helium, methane, hydrogen sulfide, ammonia, sulfur, water, all of which show up on the periodic table. Oh yeah? What is the sun made of then? Actually, the sun is made of elements number 1 and 2, hydrogen and helium, right off the periodic table. So what is the universe made of then? Well, by definition, the periodic table of elements is every known element in the universe. So the universe is made up of the periodic table, right? It's mostly elements 1 and 2, hydrogen and helium, and then it's a varying mixture of all the other elements out there. All right, thanks for joining me on an overview of the science of chemistry. Thanks a lot. See you later.